I wanted to give you a couple of problems where we are adding and subtracting rational expressions. I know some of you have asked about this, and so I wanted to make sure I gave you this information, gave you some examples here. And so I want to start with adding, and you can see the two rational expressions we're going to add. Before we can add these two fractions together, we have to get this denominator and this denominator to be the same. If they're not the same, we cannot put them together. And so to be able to get them the same, we got to figure out what our least common denominator is. And so what we're going to do is we're going to take this first denominator and we're going to factor it using reverse FOIL. And so when we do that, we're looking for two numbers that are going to multiply to give 2, that are going to add to give 3, which are going to be 2 and 1. And then our signs are going to be the same. They're both going to be positive. And then I'm going to mark out this trinomial just because I've already used it and factored it, just so you're not confused there. Now, on this other trinomial, we're going to do the same thing. We're going to factor it using reverse FOIL. We're looking for two numbers that will multiply to give 5. They need to add to give 6, which would be 5 and 1. And then our signs are going to be the same. Both going to get the positive. Again, I'm going to mark out that trinomial. So that factoring is like we've done before. It's simply just finding that all we're doing there is just factoring using that reverse FOIL. Now, I'm going to write my least common denominator here at the bottom just so I have some room to write it. And in our least common denominator, we have to have both this m plus 2 and m plus 1, that whole denominator, and we've got to have this whole denominator, this m plus 5 and m plus 1. So when we list our least common denominator, we're going to start by putting all of this, the m plus 2 and m plus 1, in our common denominator. So we've got our m plus 2 and m plus 1. That is the first denominator. We also need all of this denominator, the m plus 5 and m plus 1 both. But we've already got this m plus 1. We don't have to put it again because it's already there. But we do need this m plus 5. And so we're going to add that. So we have m plus 5. And now this m plus 2, m plus 1, m plus 5 is all our least common denominator. Now, we want to make sure that we make both of these denominators be this common denominator on the bottom. Okay, that's what we're trying to get. We're trying to get all three of these factors in each of these. So we want that there, we want it there. And if you look at this first fraction and look at what it's missing, it does not have the m plus 5. It's got the m plus 2, it's got the m plus 1, it does not have that m plus 5. And so we need to multiply this first fraction by m plus 5 on the top and on the bottom. And so what we're going to do is we're going to take that and we're going to multiply the top by m plus 5 and the bottom by m plus 5. And the reason we use m plus 5 is because m plus 5 divided by m plus 5 is just 1, and multiplying by 1 is not going to change the value of this fraction. And so that's what we want to do. But you'll notice that now on the bottom we're going to have m plus 5, m plus 2, m plus 1, which is this common denominator that we've talked about. Okay. Now, in the second fraction, we want to do the same thing. We want to take whatever it doesn't have on the bottom and multiply by it. And so in this case, it does not have the m plus 2. It's got the m plus 5, it's got the m plus 1, doesn't have m plus 2. So that's what we're going to multiply by. And so we will multiply by m plus 2 on the top and on the bottom. Now, when you look at that, before we actually do the multiplication, we're going to see that now on the bottom of both of those fractions, we're going to have those same three factors. We're going to have m plus 5, m plus 2, m plus 1 in both of them. And so now we actually need to multiply. And so we will start by taking this 4m and distributing it. When we multiply 4m times m, we're going to get 4m squared. And then 4m times 5 is going to be 20m. And now on the bottom we have this common denominator of m plus 5, m plus 2, and m plus 1. I've had people ask in the past, does it matter if those three factors are listed in the same order? The answer to that is no. As long as you have all three of them, it does not matter the order of those. Now, on the top of the second fraction, we are going to need to FOIL this m2 minus 1 times m plus 2. That's going to get multiplied together. So just use the FOIL method, box method, however you want to do that, but you got to get both of those multiplied together. When you do, you should end up with the trinomial 2m squared. When you do your outer and inner terms, the 2m times 2 is 4m, and the negative 1 times m is negative m. So 4m minus m is going to be 3m. It is positive. And then the negative 1 times 2 is negative 2. And again, all of that is still over this common denominator of m plus 5, m plus 1, and m plus 2. Now, if we look at what we have, we now have two fractions that do have the same denominator. We're now ready to combine those together. When we combine them, we're just simply adding like terms on the top. So across the top, all these terms that are like terms just get added together. The bottom is going to stay on the bottom because that's our whole purpose. We're trying to get that common denominator. We're going to keep it on the bottom. So when you add those like terms on the top, the 4m squared plus 2m squared is going to be 6m squared. And then the 20m and 3m are going to get added together. It's going to be 23m. And then this negative 2 doesn't have anything to combine with, so we're just going to bring that negative 2 down. And on the bottom, we still have that common denominator of m plus 5, m plus 2, and m plus 1. So at this point, if you could factor this trinomial and simplify by dividing a factor out of top and bottom, then we would try to do that. But in this case, if we were to factor that trinomial, we're going to use bottoms up. And so you'd multiply the 6 times this negative 2 and get negative 12. But then you'd be looking for a number that multiplies to give 12 that will subtract to give 23. Well, nothing's going to multiply to give 12 and subtract to give 23. So that's not going to be able to be factored. And since it can't be factored, then this is now our final answer. The only difference in the addition and subtraction, just to kind of show you here, if this sign had been a negative, and so instead of addition we have a subtraction problem, that negative then applies to everything on the top of the second fraction. And so what you would need to do is distribute that negative to each of these, which would just change its signs. And then you would still go ahead and combine your like terms to get whatever this would be on the top. And then again, if you can factor and you can simplify, then you want to do that. And so that's the only difference between addition and subtraction. Everything else is exactly the same. That same process, same steps, everything. So if you can do this problem, you probably can do most any addition or subtraction problem that I could give you.